Welcome back again, everybody. We're in the midst of section 3.1. This is a very theoretical section. It's the only time you're going to see it in this course, complex numbers, but it certainly is a huge part of your future. As long as you're going to the calculus series, you will see it in Calc 2. And so we defined it. We talked very theoretically about what a complex number is, and then the complex plane and how you plot these points with these numbers. You actually plot numbers, and then we added, subtracted, and multiplied numbers, and came up with another number. You know, so that's how we add another. We add another dimension here in terms of higher level mathematics. But what we didn't do is dividing complex numbers. Oh, numbers. And so what we're talking about, let's see, there's a complex number, a plus bi. Well, let's just review, I guess. This is the real part. Well, a and b are both real numbers. A, b are both real numbers. But you call this the real part and not the imaginary part. And so that's a complex number, and that's how you theoretically write it. And then we did c plus di. And again, we added them, we subtracted them, we multiplied them, but we have yet to divide them. So what does dividing complex numbers mean? Look at that. Let's just example. What is dividing complex numbers? Suppose this is you've been taught since Algebra 1 that you don't want to divide by irrational number, and what you would do then is multiply, by 1, disguise as square root, and so this is the square root of 2 over 2. Well, we're going to do the same thing. So what we're looking at, divide by. We want to divide complex numbers. Now, so what does that mean? We take one complex number divided by another. We want another complex number. We want x plus yi. We want another complex number. But so how do you divide? There's a binomial then here. You can't divide by a binomial. 5 plus x over x minus 2. You can't divide by the binomial. I mean, you can't do polynomial division. Sorry, that was a lousy example. You can't divide by the binomial. So what do you do? Well, we're going to do something similar to this. We're going to make the denominator real. Make the denominator real. We're converting it to a real number. An element of the real number system for the denominator. So here we go. So let's just look at the denominator. The bottom, the divisor, the divisor. Yeah, we'll call it that. Just look at the denominator. It's a plus bi. A plus bi. And so we want to make this a real number. We want to multiply by something. Here we chose the square root of 2 to make that a real number. Well, what can we multiply by? Well, something called a conjugate. It's a complex conjugate. Actually, all real numbers have all binomials have a conjugate. But there's a complex conjugate because we notice if we multiply those two together, you'll get a real number. The conjugate of a plus bi is a minus bi. So let's multiply a squared and plus a b. What that's on? Minus abi plus abi minus b squared minus bi squared. B squared. B squared. I squared. Look, boom, gone. Those two subtract out. They're gone. The imaginary part is gone. Because that's negative 1. A squared minus b squared, I squared. Well, what is I squared? The definition of I squared is negative 1. The definition of I is the square root of negative 1. So the square root of negative 1, that's negative 1, so it's a plus. So when you multiply a complex number by its conjugate, you'll get a squared plus b squared. You'll get a real number. All right. Example, I suppose. Is that what we're doing in 1 5? How about up here? 2 plus 5i divided by 4 minus I. Divide. Just divide. 2 plus 5i. 4 minus I. I want to divide them. How do you do that? Well, we need the conjugate, the complex conjugate of this. And we're going to multiply 4 minus I. Oh, excuse me. Jeez, Brad. Oh, I'm so sorry about that. This is 4 minus I. We're going to multiply it by 4 plus I. Because 4 minus I times 4 plus I is 16 plus I, 4i minus 4i minus I squared. That's a real number. That's what we want. So we choose that. But just like we had the square root of 2 example, well, you got to do it, you can't change the value of the number, so you got to multiply by 1. This is 17. The bottom of that thing is 17. I'm not even going to mess with that. It's just 17. The top, because it's up here. The top, now we're talking. You have to multiply those two. 8 plus 2i. I'm foiling. Plus 20i. Plus 5i squared. The top, the 17th on the bottom, is 8 plus 22i minus 5. Please understand that's where we are right now. Minus 5. 8 minus 5. 3 plus 22i over 17. But we want a real part and an imaginary part. There we go. I divided those 2 points, and I got another point. Please understand the significance of that for later. We took a point on the plane, and we divided it by another point on the plane, and we got a quotient that is another point on the plane. Vector analysis is right here. One last thing. I don't think I'm asking you to do this, but the book, there's a Triad Problem that we're going to do in a little bit. And it's just x squared plus 5x. No. X squared plus 5x. Find, determine, I think that's it. Whatever. If you understand what the heck we're doing, this is, all I'm doing is 2 plus I squared plus 5 times 2 plus I. This is a function at x, and then this is the point we want to. We find the function's value at 2 plus I. And so 2 plus I squared, 4 plus 4i plus I squared plus 10 plus 5i. It's just algebra. Like I say, this particular section is great for you to practice your algebra skills. So this is minus 1. I don't know. Writing all it down, minus 1 plus 10 plus 5i. Group similar terms. The real part is 4 minus 1 is 3 plus 10. 13. The imaginary part, 4 and 5. There you go. The function x squared plus 5x value at 2 plus I is 13 plus 9i. Hey, thanks for listening. We'll try the Triad Problems, and then we'll be finished.